So I want in this video to look into Pluri Biotech's bioreactor. As we've learned up until now, stir tank reactors are the current industry default. So then we saw Arc Biotech in another video, and they're making airlift bioreactors. The idea is that you don't have that stirring of the propeller, and so you're able to use oxygen to circulate the media, which is gentler on the cells. There are cons to that process where you maybe have less control of the mixing, or it's possible to form gas bubbles. Currently promising and possible for cost-efficient production, especially with suspension adapted cells. So with Pluri Biotech, they're using another type of bioreactor, which is a packed bed bioreactor. So this is ideal for cells that need to adhere to something, for example, muscle cells. You can better mimic tissue structure. There's no agitation or shear with stirring a stir tank bioreactor, and you can control the media flow around the cells, as we can see in this photo. It's hard to scale it because the flow of the media can be uneven around the cells. Harvesting can be a bit more difficult, and sampling is a bit more complicated. There's a strong case that we could use this for cultivated meat or scaffold-based systems. So this is the promise of what Pluri Biotech is looking at. And I just want to go over a few articles. This was written back in 2024 by the Cell Base. In the context of bioreactors for cultivated meat production, a packed bed typically consists of scaffold materials that provide a substrate for cell attachment and growth. These scaffolds are arranged densely within the bioreactor, allowing for efficient use of space and optimal interaction between cells and the growth medium. The packed bed configuration helps to maximize surface area for cell adhesion and nutrient exchange. Pluri's proprietary bioreactor system provides a 3D microenvironment for cells that can mimic various cell growth environments using scaffolds in a packed bed bioreactor. When the cells adhere to the scaffolds, they extract extracellular matrix components and expand rapidly, transforming into products and solutions. Since the cells are attached to the scaffolds, we created a design of packet bed flow chambers connected to a feeding bioreactor. The flow to each chamber is controlled in order to maintain low shear and laminar flow, allowing us to preserve the cell's quality. In this design, we can scale the feeding bioreactor by any size, apply the needed forces for mixing and homogenization, and connect it to several flow chambers. This design leads to the ability to scale the system to different industries, including the cultivated meat sector and the plant cell culture. So for their subsidiary Ever After Foods, that startup uses edible plant-based scaffolds within its bioreactors, and those scaffolds are packed in columns and can be sterilized and seated inside the bioreactor in a scalable way. As these scaffolds are very porous with a high surface to volume ratio, we've been able to create an ideal environment for efficient cell attachment and proliferation. We can get 6 times more protein and 25 times more collagen from a cell before differentiation, and upon differentiation we can get 80 times more muscle-related proteins and 700 times more lipids. Ever After Foods' edible bed bioreactor is said to facilitate the production of cell-based meat on a high scale, while the cultivated product to bioreactor working volume ratio for stir tank is limited at only 2 to 5%, our system can produce inefficiencies of 40 to 50%. I'm assuming that means efficiencies of 40 to 50%. With such efficiencies, our current pilot system produces more than 10 kilos of cultivated meat from only 25 liters of edible packed beds. Back in June of 2024, secured $10 million to grow that bioreactor platform from investors in the EU and the US. And then in January of 2025, they acquired a stake in Kokomoto, and they're looking to apply that technology, that bioreactor technology, into the production of Kokomoto cocoa and into plant cell culture. So from day one, we have been growing cells in packed bed reactors that allow us to achieve real scale in relatively small bioreactors, as their system is 20 times more efficient than a typical steel bioreactor. where cells grow in suspension. Our plan is to move aggressively and quickly to bring these solutions to market, and our first step is to use bioreactors with 5 chambers of 200 liters each, capable of producing hundreds of kilos of cocoa and coffee. We anticipate that in 2026, this system will be available from Pluri for manufacturing across our subsidiaries. So they have been using the system in cultivated meat, and they're anticipating that by next year they will start using this for manufacturing in their plant cell culture companies. We are already discussing with players in the coffee and chocolate industry that are showing very significant interest in our solutions. So far, what we have found are many companies, first generation companies, using stir tanked bioreactors. Then we have ARC, who is trying to build a different kind of a system, an airflow system. And then we now have Pluri, which is trying to build a fixed bed bioreactor system. So we have yet to see if they will be successful, but this is currently what the landscape looks like. Thanks always for watching. We'll catch you in the next video.